Hi, folks. I'm Matt. Winnipeg is awesome, but it's freezing up here. And notable because 3 layers down, I have a B-Sides New York City cert on. If you've never been to B-Sides in New York, you should come sometime. It is fantastic. I have a New York-centric Twitter handle because that's where I lived when Twitter started, and you could still get the 5-character handles. That doesn't work anymore either. I'm on the security team at a company with a local office called Priceline, and I'm neither a pen tester nor a developer. I just know enough to cause some trouble. This is a discussion of what are called online skimmers. You may have heard of the mage card attacks earlier this year that hit companies like Newegg, British Airways, and Ticketmaster in the UK. These are pretty advanced attacks. The adversaries also target the Magento shopping cart system. I'm going to talk a little bit about where the attacks come from, how they get into your system, and some potential protections. So everyone knows what the old school credit card skimmer is, right? A piece of hardware that you put on an old card reader, like in the States where they still have the mag stripes, and it either copies the stripe data off of the card and stores it locally, or sends it back home with a cell modem. In either case, the result's the same. Someone is buying a lot of flat screen TVs with your credit card number. Because of chip and pin, chip and sign, these attacks have gotten less effective, so the same actors have taken their attacks online. This is some example JavaScript that was found in the wild on one of those companies I mentioned, slightly modified for our presentation. And this, 12 lines or something, will grab credit card data and send it off to a malicious third party. So the code somehow gets injected into the site. We'll talk about how that happens. And sits in wait until the customer hits submit or does something that involves sensitive data. Then it fires off and sends a copy of all of your data to a third-party website. For the purposes of our demonstration, we're using this cloud CDN DDNS.net skimming. Pretend that's a malicious website. It's actually running on my buddy's Raspberry Pi right now, so please don't crash it. So this is a black skimmer. It's native to, the southeastern coast in the US. It's got this weird underbright bill, and it can fly through the water and scoop up fish. And that is my transitional slide. So this is a fake example website we set up. It sells jokes. It's the riddle. Okay? And I'm not brave enough to do live demos. My hands will shake. So I'm just going to play the video and talk you through it. This is set up without a CSP. Don't worry, I'll explain to you what that is later. You can see it's the riddle. We are buying jokes here. And down here, we'll scroll up. This is the same malicious code I showed you earlier. It's running in the background on this website. It's loaded somehow in the browser. And you can see again the malicious domain cloud CDN/skimming. Customer comes in here, gives his name. He's found the jokes he wants, puts in his very valid credit card number, passes a LUN check, puts in the CVV, etc., submits it. This is our post-checkout page, right? Action page PHP. That pause. So Mike, the last speaker before dinner, had a lot of great tips in burp, and burp is my comfort zone. I love working with the intercepting proxy. So my challenge for myself for this talk was to do everything in the Chrome inspector pane, so I'm not flipping back and forth, and it's amazing what you can get out of there. So in the inspector pane, you see we posted to action page with the checkout data, as you would expect. Got a 200 back. This is our legitimate domain where we're selling jokes. And you can see we posted all the data just like you'd expect with a very basic online shopping cart. All that data gets posted home to the website. But you can see that the browser also made a connection to Cloud CDN, our malicious site, posted up more data to that endpoint, and when we roll down, you'll see it took all of the form data, made a nice serialized JSON object here, and sent it on as well. All the credit card data on the site was stolen. This is the exact attack that hit one of those companies I mentioned before. You don't need to see it again. Please skip, skip, skip. Okay, so these attacks rely on very little code. They're super simple, right? Typically, they fire only on the checkout page. You don't need it everywhere. And they siphon the data off to a malicious domain that, I don't know, passes a smell test. Here are some of the examples from past attacks. And I know if I was looking at the connections my browser was making, or if I was reading through the code in the website, and I saw a new relc.com, I'd probably let that pass. Oh yeah, it's New Relic. Yeah, people are dropping vowels these days. All of these domains were set up with CA certs, so you didn't get any mixed content warnings. And these attacks are completely transparent to the user. The user is not going to know this is happening unless you're doing a lot more inspection than any of my customers do. All of these domains are taking advantage of a nature of attack called typo squatting, and that's relevant both here and later on, right? It's where you take a domain name or a package name that people are going to trust and look for a variation on it. A lot of sites these days, if you're smart, right, you don't want to handle credit card data, you don't want to pay the compliance costs. So you bring in a third party to send the credit card data to, and then you just work with a token. However, due to the nature of these attacks, if someone can inject code into your website, they can inject a fake checkout form and gather all of this data, send it to your legitimate third-party processor, as well as sending it off to themselves. One of the most recent attacks by this group, MageCard, did just that. So how is the code getting into websites? Some of these examples are known from the public disclosures about those attacks, and some of this is speculation. Obviously, if you're serving your web content with mutable servers and an adversary can get on there, they can change what's served. If they can't get onto your servers, or if that's not the path of least resistance, they could get access to your code repository. If you've got a developer who reuses her password from more than one place, that would be a very good avenue of attack. Or if you can just, slip a developer a couple $1,000, give them one of the flat screens you know you're going to get later on. All of those are viable ways of getting in. Similar to the domain type of squatting, there is more and more typo squatting in the third-party library space for web code. So, is that PyPy or PyPy? I think it's PyPy, right? Anyone? Someone say yes, right? So, thank you. So these are all third-party libraries that were found in the Python public repos. And they are squatting on the name of Django, which is the web framework. Slight misspellings. These packages all provide the same functionality, same code as Django, but they also include some extra maliciousness to siphon off sensitive data and send it away. We know that for one of the companies that fell victim to these attacks, the malicious code was injected to their site through cross-site scripting. We know that one of the companies who fell victim to this attack, actually their servers and everything else were pristine, but they were bringing in some third-party code on their checkout page. If you've ever seen the little chat window that pops up, hey, do you need help with this purchase? Instead of compromising the first party, the attackers compromised that chat provider. Because that JavaScript was running on the checkout page, the adversary was able to copy off all of the sensitive content. Malicious browser plugins, not used in the attacks we've seen so far, but it's the same idea. Either through typo squatting or finding an abandoned plugin and buying it up from the developer. That's two more ways to observe traffic in the web browser and steal it off. So what can we do about this? First, there are some really good IOCs out there for these attacks. Go See the Dog has a few thousand host names, IP addresses, and whois details for domains that were registered in the most recent attacks. You can scan your code repos for these. You can look at your DNS logs. You can look at your network telemetry to see if you see anything related to these. When you get in there, your heart sinks a little bit because you see all of these domain names that are very similar to something you may be familiar with and something that you realize if you saw it listed in a website, you'd not think twice about it. There are several other great write-ups about this. Links are at the end. Commercial company Risk IQ has done a ton of research. There's this Dutch guy, Willem, who has a great blog covering all of this. Beyond that, beyond the network telemetry and looking into repos for IOCs of previous compromise, you need to have great integrity controls to prevent this malicious code from getting into your site. First, you want strong auth to your code repos. A stolen password from a developer should not be enough to bring down your site. Turn on 2FA for all of that. You need to have some degree of peer review before the code gets out so that if a developer is subverted, it would be detected. When you're bringing in third-party libraries to your code, you should check them for vulnerabilities as well as maliciousness and typo squatting. Retire.js, OWASP dependency check are a couple open source tools to help you with some of that. If your repo is clean, you need to detect and alert on changes to the servers, if they're mutable servers, right? So some sort of file integrity monitoring over the objects that get loaded onto there and get served out to your customers. Ideally, what's in the repo, what's on the server, and what runs in the browser can all be hashed and compares. And there are ways to assert the hash of the third-party or first-party resource to the browser so that the browser will only run the script if it matches the hash. Finally, you need to look at your site from an outside perspective. So sandbox it somehow. I would expect evasive techniques here, meaning don't only load your site from your network, don't only load your site from Selenium or Phantom.js and expect that to detect all of these changes. You need to have real emulation, real people, looking at the site from anonymous networks. You need to inventory all the third-party scripts, pixels, et cetera, that you're loading. You need to do a smell check against those, and that will help you in the next step in the policies you can develop to assert positively what the browser is allowed to connect to. So the best protection against getting these online skimmers injected to your site is to use a header called a content security policy. This gives you really fine-grained control over what you allow the browser to connect to when it's on your site. CSP is a header that you set in the web server, so Apache, Nginx, whatever. It's a whitelist or a blacklist of what you allow people to connect to. There are a lot of directives within the header you can set. Anything that ends in SRC takes what's called a source list. It's a list of domains that you allowed the browser to connect to for those particular types of objects. So style SRC is the list of domains that you want the browser to connect to get a style sheet. Two important ones at the end, the report URI. That's an endpoint that the browser is going to post any CSP violations to. So if you're implementing a CSP and you break something, you have a method to know that telemetry from the browser. SHA-256 is another directive you can put in the header to specify the exact hash of the asset you want it to load. So there's a very well-named website called contentsecuritypolicy.com. It has a bunch of examples, stolen blindly from there. The most simplest CSP you can assert through a header is default SRC self. That just tells the browser, load any assets that are from the same origin, right? From the same URL, same domain name. You can be a little more advanced. A lot of people run GA, right? This is a basic policy that lets you load Google Analytics. To get a little more complicated, if you do default SRC none, yeah, I know there's a laser pointer, but I like to stretch. If you do the default SRC none, that's a default deny, and then you say you only allow scripts, connect, that's an AJAX call, images and style sheets from the same origin. This looks great. Many sites load dozens or scores of third-party assets, pixels, scripts, etc. How do you get to somewhere where you can implement this sanely? So, got an example from the same joke store before. Now it's expressing this content security policy. So this is the additional header that the web server is sending. Everything else is the same. I'll show you how this works. So again, it's the same checkout form. All the same information is gathered. Same malicious JavaScript running, posting to the same cloud CDN, DDNS.net endpoint. Same customer buying the same jokes. Give it the customer name. Hey, does anyone know what 14 North Moore Street in Tribeca is? It's a famous 80s movie firehouse. I get no, oh yeah, okay, finally, someone like me got it. So we checked out here. We posted to our checkout page, and you can see again, the same information was sent. Got a 200, submitted all the same payment data. This is fine, this is coming back to me. However, the connection to the skimming endpoint was blocked. The browser said, no, it violates the CSP, I'm not going to do it. This is the message the browser will send back if you specify a reporting endpoint. So you can see something has changed on the site. Chances are a developer just updated something, but maybe we have some malicious code running that's trying to siphon data outside. This is a durable method, meaning as we reload several times, you'll continue to see it being blocked. And this is the magic of the inspector. I would have had to show you all of this in burp. There would have been a lot of flipping back and forth. You would have not liked it. Again, feeling old, but these tools are so cool. So, how do you get started implementing one of these on your site? First, develop an inventory of the sensitive pages and the third-party resources you're bringing in on those pages. So are you firing Google Analytics? Do you have marketing pixels, etc.? You don't need to run this everywhere. Focus on the pages that collect sensitive data. There is a separate header you can set that is called Content Security Policy Report Only. Takes all the same syntax, but it won't block anything. It will simply send data back to your reporting endpoint saying, hey, my policy said I shouldn't have connected to this place. I'm connecting to it anyway, but I thought you should know. You don't need to run a CSP on all of your traffic, either for initial implementation, or you could argue at all, right? If you are getting a relatively good subset and you know you've got good coverage, maybe you don't need it everywhere. Google has a great syntax validator for the CSP when you implement it to tell you if you've got any syntax bugs. So, in summary, first you need strong source code control. You need to be able to connect what's in your repo, what's on the server, what's running in the browser. If you hash all of those, you can compare in the browser with the SRI directive or with the hash directive in the header to make sure that what your browser is running is what you expect it to be. You need great integrity monitoring on the servers. Make them immutable. Maybe you don't care about this. But if you're running actual web servers and something changes and it's outside of your expectations, you should know about that right away. You need a process within your repo to notice third-party libraries with vulnerabilities. What's good today may not be so good tomorrow. You need to inventory what you've got today. I know in my case it's hundreds of tracking pixels, but not on the checkout page. Once you've got that baseline, then you work to build the CSP. You start it with report only. You move it on into blocking when you're ready and when you know what effect it's going to have. You use hashing or SRIs to do that full integrity check across the chain. And you look at your site from an external perspective. Run it from a phone off the network, run it from a browser off the network. Make sure that there's not an evasive technique to prevent you from seeing malicious code running there. Real quick commercial, I work for a great company. We're hiring here dev managers, developers, co-ops, and any security people who want to live in an exciting place, work with me in New York. work in Bangkok, work in Amsterdam, work in the UK. Booking.com, Priceline, OpenTable, Kayak, we all have openings. We all work together, it's a fun team. Here are a bunch of references that will be posted online very soon. Any questions? Ooh, question, yo.
Will the CSP cover the malicious plugin scenario?
Browser plugin? Probably not, right? Let's see. I don't know the order of operations there. And the CSP won't help if someone can change the CSP, right? If you're that screwed and you can't detect a change in the CSP, you've got no luck. The way a browser plugin would work, if it could, I don't know, save it to local storage and then send it up later, that wouldn't be observed by the CSP. Cool, thanks guys.